This is section 1.6, solving inequalities. Simple linear inequalities. A linear inequality is like a linear equation with the equal sign replaced with one of the following inequality symbols. Less than or equal to, greater than or equal to. Okay, these two that I put the asterisk by, the less than and the greater than, those are called strict inequalities. So less than and greater than are referred to as strict inequalities since they do not allow for the possibility of equality. So in terms of the interval notation, those are the ones that you would use a parenthesis. The ones with the possibility of equal to, those are the ones that you would use the bracket if you were writing interval notation. Solving inequalities. Okay, solving inequalities is like solving an equation, except you must reverse the direction of the inequality if you multiply or divide by a negative number. So remember, if you multiply or divide by a negative number, then you change the direction of the inequality. So it's kind of like after you have all your x's together, all your numbers together, if there is a minus coefficient for the variable, then you will be changing the direction of the inequality. As an illustration, we know that negative 2 is less than 15. If I multiply both sides by negative 1, okay, this will become positive 2, this will become negative 15. And notice, if I kept that direction the same, it would be a false statement. So the less than becomes a greater than. So again, if you did not reverse direction, the statement would be false. So if you multiply or divide an inequality by a negative number, you have to change the direction of the inequality. So when presenting the solution to an inequality, you must include the following. Number 1, the inequality symbol. Okay, and don't accidentally change it to an equals. Right? Number 2, the variable. And lastly, the numerical value that you have found. So you have to include all those things when you're presenting the solution to an inequality. If you don't want to do it this way, the alternative is use interval notation. Okay, oftentimes the directions will actually tell you to use interval notation. So classify each statement excuse me, as true or false. So we've got 6 statements there, and you're just going to answer true or false. Okay, the first one, 6 less than 6. That's false. A number is not less than itself. It's also not greater than itself. So that's false. Number 2, 6 is less than or equal to 6. This is true. It satisfies the equal portion. Number 3, 7 greater than negative 6. Yes, that's true. All positive numbers are greater than negative numbers. Number 4, 12 is greater than or equal to 0. That's true. That satisfies the greater than part. Number 5, negative 6 is less than 0. Yes, that's true. Negative numbers are less than 0. And lastly, number 6, 14 is greater than or equal to 9. That's also true. It satisfies the greater than part. Let's try some examples where we solve inequalities. Now again, remember, with inequalities, it's just like solving an equation. Get your x's together, get your numbers together. We also clear fractions if we see fractions. It's just that you have to remember to multiply or divide. When you multiply or divide by a negative number, you change the direction of the inequality. So solve for x, simplify your answers. Do not use mixed numbers or decimals in your answers, and express your answers using interval notation. So we have this little extra sentence here in our usual directions for solving for x. Here's our first one. I've got 3x minus 12 is greater than or equal to 14. Again, the idea is to get the x's together, get the numbers together. So we're going to add 12 to both sides. So that would give us 3x is greater than or equal to 26. Then we're going to divide by 3. We're not dividing by a negative number, so the inequality keeps the same direction. So I'll have x is greater than or equal to 26 thirds. Okay, when I write the interval notation, I'm going to have a bracket at 26 thirds, and it will go out to infinity. If you keep the variable on the left, which is actually where we prefer, the direction of the inequality will point in the direction of the infinity you use. It's pointing to the right, so I want the infinity that's on the right. And again, remember, you always put a parenthesis at an infinity. You never put brackets at infinities. And because it says it could equal, that's the reason we have a bracket for the 26 thirds. Number 2, I have 2 thirds times 4x minus 5 is less than 1/2 minus x. Again, I want to get rid of the fraction. So I'm going to clear fractions. My LCD for 2 and 3 is 6. Remember, when you clear fractions, don't go inside the parentheses. So I'm going to multiply everybody by 6. So 2 thirds times 6 gives me 4. So 4x minus 5 is less than 3 minus 6x. Now again, multiply all the expressions that are outside parentheses, multiplying by 6, that's where we get these new numbers. Okay, now we'll distribute the 4. So I'm going to have 16x minus 20 is less than 3 minus 6x. Okay, now we want to get x's together, numbers together. So we'll add 6x and add 20. So I'll have 22x is less than 23. Now we divide by 22. So x is less than 23 over 22. Now again, we divided by a positive number, so we don't change the direction. Okay, the variable is on the left. The inequality points to the left, so I want the infinity that's on the left, that's minus infinity. So I'm going to have the open interval from minus infinity to 23 over 22. Okay, now again, the parenthesis for 23 over 22 because it was a strict inequality. Remember, the strict inequalities use the parentheses. The ones that allow for equal use the brackets, and you always put a parenthesis for infinities. Number 3, I have 4 minus 7x is less than or equal to 18. Okay, now again, the idea is get the x's together, get the numbers together. So let's subtract 4 from both sides. So I have negative 7x is less than or equal to 14. Okay, we're now about to divide by negative 7. Because we're dividing by a negative number, the inequality will change direction. So I'm going to have x is greater than or equal to negative 2. So again, if you multiply or divide an inequality by a negative number, you change the direction. Okay, so this is going to be a bracket at negative 2 and then out to infinity. Number 4, I have negative 6x is greater than or equal to 0. Okay, I want to divide by negative 6. I'm dividing by a negative number. The inequality changes direction. So I'll have x is less than or equal to 0. Okay, don't write 0 over negative 6. 0 over negative 6 is 0. Remember, 0 over a non-zero number is 0. And again, the inequality changed direction because we divided by a negative number. So I'm going to have minus infinity to 0 with a bracket at the 0. Okay, the second problem with domain. Back when we first talked about domain with functions, we said we would encounter the second problem in section 1.6. We are in section 1.6. So recall that the first problem with domain was that you could not have anything equivalent to 0 in a denominator. So you set the denominator equal to 0 and solve. So the second problem is that you cannot take an even root of a negative number. So no square roots of negatives, no fourth roots of negatives, no sixth roots of negatives, and so on. It's okay to take an odd root of a negative, but no even roots of negatives. We only deal with real numbers. So remember, it's okay to take an odd root of a negative number. For instance, the cube root of negative 1 is negative 1. So our two problems with domain are even roots and denominators. So the summary of the domain problems. Okay, this is without going to the special functions, which we will not see until chapter 5. So number 1, if there is a variable expression in the denominator without a radical, step 1, set the denominator equal to 0 and solve. Step 2, the values that you have found from step 1 are excluded from the domain. This is what we've already done in section 1.4. Okay. Number 2, if there is an even root in the numerator. Okay, so like the square root of 17x plus 11. Set the expression under the radical greater than or equal to 0 and solve. Okay, so the expression under the radical is set greater than or equal to 0 and you solve. So you're solving an inequality. Step 2, what you have found from step 1 is the domain. Number 3, if there is an even root in the denominator, like 1 over the square root of 2x plus 5. Step 1, set the expression under the radical greater than 0 and solve. Notice the difference. If it's in the numerator, it's greater than or equal to. If it's in the denominator, it's strictly greater than. So you're solving an inequality. And again, step 2, what you have found from step 1 is the domain. If there is no variable expression in the denominator and there are no even roots, then the domain is all real numbers. Let's try some examples of finding domains. Now some of them we've already done before. So some examples. Find the domain of each function. Simplify your answers. Do not use mixed numbers or decimals in your answers. So it's kind of like solving an equation or inequality. That's why the directions are so similar. Here's our first one. I've got f of x is 3x squared minus 7x plus 11. Okay, so you look for variables in the denominator. I don't see any. You look for even radicals. I don't see any. So the domain is all real numbers. Again, because there is no denominator and no even roots. So this, remember, minus infinity to infinity, that's the interval notation for all real numbers. Please don't forget that. Number 2, I've got g of x is 3x minus 7 over 4x plus 8. Okay, I do see a variable in the denominator, so we're going to find where the denominator is equal to 0, and the domain will be everything else. So 4x plus 8 equals 0. Just the denominator. Don't worry about the numerator. Remember, where the numerator is 0, those are the zeros of the function, which correspond to the x values for the x-intercepts. So 4x plus 8 equals 0. Subtract 8. 4x is equal to negative 8. Divide by 4. X is equal to negative 2. So that's the value we exclude from the domain. So it's like domain is all real numbers except for negative 2. If you were asked to write interval notation, it would be minus infinity to minus 2, union minus 2 to infinity, and you would have parentheses for all parts of the interval notation. So there's the set notation, there's the interval notation. Again, in the problems, read the directions to see is there a specific form you were supposed to write your answer in. These examples didn't give a specific form. Number 3. I've got h of x equal to the square root of 4x minus 12. Okay, we don't have any denominators, but we do have an even root. So cannot take the square root of a negative number. So we need the expression of the radical, the 4x minus 12, greater than or equal to 0. It's okay to take the square root of 0. The square root of 0 is 0. So we're solving an inequality. Add 12. So again, we're actually finding the domain. With the even roots, you're actually finding the domain. So add 12 to both sides. 4x greater than or equal to 12. Divide by 4. X is greater than or equal to 3. Okay, you can leave it like that because there was no specific form for the answer, or you could use interval notation 3 to infinity. Okay, with a bracket at the 3. Number 4. I have k of x is 2x plus 11 over the square root of 5x minus 10. Again, we don't worry about the numerator. There aren't any restrictions on it. But I have a radical in the denominator now. So because 5x minus 10 is in the denominator, it cannot be 0. Remember, you still can't have 0 in the denominator. Because 5x minus 10 is under square root, it cannot be negative. So it can't be 0, can't be negative. That means it's strictly positive. That means it's greater than 0. So we're going to solve 5x minus 10 greater than 0. That will give you the domain. Okay, with the even roots, you're actually finding the domain. So to solve the inequality, add 10 to both sides. 5x greater than 10. And then divide by 5. Okay, we're dividing by a positive number. We don't change the direction of the inequality. So x greater than 2. Or if you like the interval, open interval from 2 to infinity. Number 5. P of x is equal to the cube root of 7x plus 10. Okay, I don't see any denominator. I also don't see any even radicals. I've got a cube root. It's okay to take the cube root of a negative number. It's okay to take the odd root of a negative number. It's only the even roots. So the domain is all real numbers, which would be minus infinity to infinity. Again, because no denominator and no, in this case, even roots. Emphasis on the even. It's okay to do odd roots with negatives, but not even roots. Okay, compound inequalities. Okay, remember, in mathematics, inequalities actually are statements. So it's kind of like sentences in English. So a compound statement in English has got 2 or more statements joined by the word and or something like that. Same thing in math. So 3-sided inequalities or double inequalities. Okay, I tend to call them 3-sided. The form of a 3-sided inequality or double inequality looks like this. Capital A is less than capital X is less than capital B, or you could change them to less than or equal to, or you could change the direction. Okay, where A and B are real numbers and capital X is a variable expression, like 3x minus 12 or something. Notice that both inequalities point in the same direction. They're both pointing to the left, both pointing to the right. That will always be the case. So that means if you multiply or divide by a negative number, both inequalities will change direction. Now it's 3-sided because there are 3 sides, the middle, the left, and the right. It's called a double inequality because there are 2 inequalities. Now again, remember, both inequalities must always point in the same direction, both to the left or both to the right. So in solving a 3-sided inequality, your goal is to isolate the variable in the middle. That way you can say that x is between 2 numbers. And notice when you have x is between 2 numbers, you've actually set it up for interval notation. So you're trying to isolate the variable in the middle. So we use the same techniques to solve a 3-sided inequality that we use for solving linear equations or linear equalities, except here Whatever you do to one side, you must do to the other two. Like if you're saying I'm going to add 3 to the middle, you got to add 3 to both the left and the right as well. And remember, if you multiply or divide by a negative number, both inequalities will change direction. Okay, so that way you keep both inequalities pointing in the same direction. The problem will come to you that way. Your final answer must also be that way. So never write something like this, a less than and a greater than, or something like this, as a solution of any type of inequality. No credit will be awarded if you write something like that. That doesn't even make mathematical sense. So heed the warning, don't do it. Usually if you have to write your answer as interval notation, you would not end up writing something like that. So that is one advantage to going to interval notation. It'll prevent you from writing down something that doesn't make any sense. Just that remember, with interval notation, the smaller number is always on the left. Let's solve some. So solve for x, simplify your answers, do not use mixed numbers and decimals in your answers. Express all answers using interval notation. Okay, here's our first one. I've got negative 5 is less than or equal to 5 minus 2x, which is less than 9. Again, the idea, I want to get x stuck in the middle. So I'm going to subtract 5 from all three sides. Because of this 5 right here, I'm going to get x in the middle. So subtract 5 from all three sides. I'll have negative 10 is less than or equal to negative 2x, which is less than 4. Now again, to get x in the middle, I've got to divide by negative 2. Got to divide by the coefficient of x. I'm dividing by a negative number. Both of these inequalities will change direction. So divide by negative 2 and reverse both inequalities. I'll have 5 is greater than or equal to x, which is greater than negative 2. Now, if it weren't for that last sentence that said to switch to interval notation, you're actually done. Remember, with interval notation, the smaller number must be on the left. The smaller number is negative 2, so it'll be a parenthesis, negative 2, comma 5, and then a bracket. So the left half open interval from minus 2 to 5 is your final answer. Remember, smaller number on the left in interval notation. And if you multiply or divide by a negative number, both inequalities change direction. Number 2, I have 9 is greater than 3 minus 5x over 2, which is greater than 0. Okay, I see a fraction. So I want to clear a fraction. I multiply everything by 2. Okay, so I'll have 18 is greater than 3 minus 5x, which is greater than 0. Okay, now I want to get x in the middle, so I need to subtract 3 from all three sides. So I'm going to have 15 is greater than negative 5x, which is greater than negative 3. And to get x in the middle, divide all three sides by negative 5, and you will need to reverse both inequalities. So I'll have negative 3 is less than x, which is less than 3/5. Remember, negative over negative is positive. Okay, I now convert to interval notation. The inequalities are pointing to the left, so I can go directly to interval notation. Open interval from minus 3 to 3/5. And again, the parentheses were used because the inequalities were strict inequalities. Remember, strict inequality uses a parenthesis. The one that allows for equality uses a bracket. Let's take a look at another. Number 3. I have negative 3 is less than 2/3 x minus 1/2, which is less than or equal to 2. So let's see, we've got some fractions. I want to clear fractions. The LCD for 2 and 3 is 6. So we're going to multiply everything by 6. So I'll have negative 18 is less than 4x minus 3, which is less than or equal to 12. To get x in the middle, let's add 3 to all three sides. So I'll have negative 15 is less than 4x, which is less than or equal to positive 15. And now we're going to divide by 4. Okay, we're dividing by a positive number, so the inequalities do not change direction. So divide everything by 4. I'll have negative 15/4 is less than x is less than or equal to 15/4. Okay, now again, we've got to go to interval notation. The inequalities are pointing to the left, so I'm already set up for interval notation. I'll have a parenthesis on the left because of the strict inequality. I'll have a bracket on the right because it said it could equal. So the left half open interval from minus 15/4 to 15/4. Okay, let's go to our next type of compound inequality. Conjunctions. Okay, now in the world of English, both and or are conjunctions. In the world of mathematics, only one of them is considered a conjunction. So definition. A conjunction is two or more statements, and for us it will be inequalities, joined by the word and. You will actually see the word and in the problem. Each separate statement in a conjunction is called a conjunct. Now ideally in our answer, we want to be able to make at least one of the inequalities go away. So some properties of conjunctions. A conjunction is true if only if both conjuncts are true. Number two, graphically, we look for where the graphs of the separate inequalities overlap. So we can sometimes simplify by looking at the graphs. If the graphs of the separate inequalities do not overlap, then the original conjunction does not have a solution. Simplify with conjunctions means more than just reduce fractions. It always means reduce fractions. It means, if possible, write one and only one inequality, if possible. Because notice, if there's no solution, then you don't write any intervals. You just write no solution. So it's the graphs, the number two here, looking for where they overlap, that's going to help us get rid of one of the inequalities, one of the intervals. So we have four cases to look at. Okay, the cases are both inequalities point to the left, both point to the right, they point toward each other, they point away from each other. So some examples. Solve for x, simplify your answers, do not use mixed numbers and decimals in your answers, express all answers using notation. I want each conjunct to be kind of simple because I don't want us getting bogged down in solving inequalities. That's not the hard part. The hard part is going to be how do you get rid of one of the inequalities. So here's our first one. I've got x plus 5 is less than 3 and x plus 2 is less than 4. Okay, notice both inequalities are pointing to the left. Now this is not a three-sided inequality. That's why they can sometimes be allowed to point in opposite directions. Okay, each conjunct is kind of simple to solve. For the one on the left, subtract 5. For the one on the right, subtract 2. So I'll have x is less than negative 2 and x is less than positive 2. Okay, now that's not your final answer. I want to see if I can make one of those inequalities go away. So if you left that as your final answer, that would be wrong. So I'm now going to graph each separate inequality on the number line and look for where they overlap. Remember, with the word and, you always want to look for overlapping. So here's x less than negative 2. Okay, I'm not going to put the open dot. If you don't see the solid dot, then that means that it does include the endpoint. So there's x less than negative 2. Okay, when I do these examples, I'm always going to have the one on the left graphed in red and the one on the right graphed in blue. And here's x less than 2. Okay, now you want to find out where they overlap. Remember, the word and requires them to overlap. They start to overlap at x is less than negative 2. So that's going to be your final answer, x less than negative 2. So remember, where they overlap is your final answer. And interval notation, minus infinity to minus 2. Okay, so again, look for where they overlap. Just kind of a simple observation. When they both pointed in the same direction, we took the shorter one. Okay, so when they pointed in the same direction, the word and took the shorter one. Let's change the directions. Let's have them both point toward the right. So I have x plus 6 is greater than or equal to 1, and x plus 3 is greater than 10. Okay, yet neither inequality is difficult to solve. So for the one on the left, subtract 6, the one on the right, subtract 3. So if x is greater than or equal to negative 5, and x is greater than 7. Okay, to figure out if I can make one go away, let's graph them. Okay, here is x greater than or equal to negative 5. And then x greater than 7. Remember, I want to know where they overlap. Remember, the word and always requires them to overlap. They start to overlap at x greater than 7. And again, notice they point in the same direction. The word and took the shorter one again. So our solution is x greater than 7, which would be 7 to infinity. So again, when they point in the same direction, the word and takes the shorter one. And always wants overlapping. Number 3. This time they're pointing toward each other. And so x plus 4 is greater than or equal to 3, and x plus 2 is less than 10. Okay, solve each one and graph it, and look for where they overlap. So for the one on the left, subtract 4. For the one on the right, subtract 2. I'll have x is greater than or equal to negative 1, and x is less than 8. Okay, to figure out what's going to be my final answer, graph each one, and look for where they overlap. Remember, the word and wants overlapping. So there's x greater than or equal to negative 1. Okay, x less than 8. Okay, where do they overlap? They overlap between minus 1 and 8. It includes minus 1, but it doesn't include 8, because remember, the blue part never did include 8, strictly less than. So they overlap between minus 1 and 8, including minus 1. So it's the right half open interval from minus 1 to 8. Again, the word and wants to know where do they overlap. Number 4. X minus 3 greater than 6, and x plus 1 less than negative 4. Okay, the one on the left, add 3, the one on the right, subtract 1. So I'll have x is greater than 9, and x is less than negative 5. Okay, to figure out what our final answer is, graph them, and look for where they overlap. Okay, there's x greater than 9. X less than negative 5. Okay, we look for where they overlap. They don't overlap. So if there's no overlapping, that means there's no solution. And that's what you write, no solution. Don't write something weird. The way you indicate there's no solution is by writing no solution. Okay, now again, in English, the word or is considered a conjunction as well. In mathematics, it is not. So the next type of compound inequality, disjunctions. Definition. A disjunction is two or more statements, for us again inequalities, joined by the word or. You'll actually see the word or in the statement. So each separate statement in the disjunction is called a disjunct. Now ands never become ors, and ors never become ands. So now the properties of disjunctions. A disjunction is true if at least one of the disjunctions is true. They don't both have to be true, just one of them. So graphically, this means that we just throw the separate graphs of the separate inequalities together. Overlapping is not required. The technical name is called union. So we're actually taking the union of the two. Again, we would like to make at least one of them go away. Since overlapping is not required, a disjunction will always have a solution, but sometimes the solution may look strange. Remember, with the ands, if there was no overlapping, there was no solution. And again, number 4, simplify with disjunctions means more than just reduce fractions. It means, if possible, write one and only one inequality. Or if you're using interval notation, just one interval. Now in our examples, we're going to have the same 4 types of examples and see what happens with the word or. Students sometimes say that the ors are the opposites of the ands. That's not quite true. So, some examples. Solve for x, simplify your answers, express all answers using interval notation. Now, for the eagle eyes among you, you'll probably notice I've left out the sentence, do not use mixed numbers or decimals. Number 1, I have x plus 3 less than 10, or x minus 5 less than or equal to 17. They're both pointing toward the left. Okay, so for the inequality on the left, subtract 3. For the one on the right, add 5. So x less than 7, or x is less than or equal to 22. Again, let's graph them to see what it looks like. There's my x less than 7. Okay, x less than or equal to 22 will go like this. Okay, now if I just throw them together, all you will end up seeing is the longer one. So putting them the two together, all I see is the blue graph, the longer one. Notice that is the opposite of what the and did. The and took the shorter one. So our final answer is x less than or equal to 22, which would be minus infinity to 22. So if they point in the same direction, or takes longer and takes shorter. Okay, let's try example 2. I have x plus 1 greater than or equal to 5, or x minus 2 greater than or equal to 12. Okay, neither inequality is difficult. For the left one, subtract 1. For the right one, add 2. I've got x is greater than or equal to 4, or x greater than or equal to 14. Now again, we graph each one. There's my x greater than or equal to 4. Okay, and x greater than or equal to 14 will be here. Okay, now again, if you just throw them together, all you will see is the longer one. So again, if they point in the same direction, or takes longer and takes shorter. So our solution is 14, excuse me, x greater than or equal to 14, which would be 14 to infinity, and you put a bracket at the 14 because it did say it could equal. So 14, 4. The longer one is the 4. Okay, so bracket because it said it could equal. So again, if they point in the same direction, or takes longer and takes shorter. Remember, and always wants overlapping. Okay, the corresponding example number 3. I've got x plus 2 greater than or equal to 5, or x minus 6 less than 10. Okay, I'm going to subtract 2, and for the one on the right, add 6. So x is greater than or equal to 3, or x is less than 16. Graphically, there's x greater than or equal to 3. Okay, x less than 16 is like this. Okay, now if I imagine throwing those two together, I would get all real numbers. Because remember, and requires overlapping, or doesn't. Or just says throw the two together. So if I throw them together, if I have this overlapping type thing, for the or, it's all real numbers. Minus infinity to infinity. Notice that isn't the opposite of what the and would have done. So, like this, that's all real numbers for the or. Okay, and now the example 4. X minus 3 is greater than 5, or x plus 7 is less than 1. Okay, we'll add 3, subtract 7, so x is greater than 8, or x is less than negative 6. Okay, we graph them to figure out what's going on. Okay, there's my x greater than 8. Okay, x less than negative 6 is down here. Okay, now remember, or does not require overlapping. If you throw those two together, that's exactly what you're going to get. As funny as it looks, that is our final answer. X less than negative 6, or x greater than 8. For interval notation, minus infinity to minus 6, union 8 to infinity. Okay, so this is our funny looking answer. Remember, the and would have gave us no solution because there was no overlapping. So with an or, if there's no overlapping, you get the union of two separate intervals. So or, with no overlapping, you get two separate intervals. Okay, let's look at some inequality word problems. So, inequality word problems. Okay, our inequality word problems fall into one of two main categories. The first one, stay within budget. It's kind of like you cannot spend too much money, or you can't go over your minutes on a cell phone plan. And the other possibility is plan A versus plan B. You'll actually see plan A, plan B sometimes specifically written out. Now, don't forget that these actually are intervals or inequality problems. Students sometimes forget that and they just write down one number. The solution to an inequality is not just one number, it's a bunch. Like if you write x less than 12, there are a bunch of numbers that are less than 12. Let's try some examples. Okay, first one. A car rents for $35 per day plus 25 cents per mile. So if you just sit out in the parking lot, that's costing you $35 a day. Your travel budget allows you to spend no more than $125 per day on car rentals. If you will travel m miles per day, what values of m will allow you to stay within budget? Now notice, if you drive 0 miles, you're within budget. Also, if you drive 1.7 miles, you're within budget. So there are a lot of mileages that will allow you to stay within budget. So I want to spend no more than $125, so something is going to be less than or equal to $125. So $35 plus 25 cents per mile and m miles, so 35. Okay, so something is less than 125. So 35 plus 0.25, that's what 25 cents, right? 0.25 m is less than or equal to 125. So you are within budget. So you're solving a nice little inequality. Subtract 35. 0.25 m is less than or equal to 90. Okay, divide by 0.25. M is less than or equal to 360. Okay, now this 0 for the notation came up because you can't drive negative miles. Don't roll back the odometer. Now if you just plop down 360, that's not all the miles that'll work. Now, sometimes in my math lab I'll ask you, what is the maximum number of miles you can drive and stay within budget? That would be 360. That's the maximum you can drive. Okay, but notice if you drive 100 miles per day, you're within budget. Okay, please don't try to list all the miles. You can't. You can drive fractional miles. Number 2. A worker can be paid in one of two ways. Plan A, $200 plus $6 per hour. Plan B, straight $14 per hour. Okay, notice under Plan A, if the guy works for 1 hour, he's made $206. Under Plan B, he's only made $14. Now suppose a particular job requires H hours of work. For what values of H is Plan B better for the worker? Okay, now to be better for the worker means he's actually going to make more money. So better for the worker, again, means he makes more money. That means we need Plan B greater than Plan A. Okay, now if he wanted to know for what values is Plan A better, it would be the other way around. Plan A greater than Plan B. Now Plan B, $14 per hour, he works for H hours. That's 14H. Plan A, $200 plus $6 per hour, that's 200 plus 6H. There's your inequality. So we're solving 14H is greater than 200 plus 6H. Okay, let's get our H's to the left, so subtract 6H. So 8H greater than 200. Divide by 8. H is greater than 25. Or interval notation, 25 to infinity. So H is greater than 25 hours. Please don't say that means it's 26 hours. You can work for half an hour, you can work for 3 minutes. Okay, so don't try to list everything. Just leave the inequality. So H greater than 25 hours, or the open interval from 25 to infinity. That's the end of section 1.6. It's also the end of chapter 1.